Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from Automatic Generation Control. The name of the topic is Turbine Speed Governor System with its model. So this was the diagram that we earlier explained in a previous video. What is this ABC CDE linking mechanism? What is the purpose of that? How the speed governor will operate? What is the function of fly ball? What is hydraulic amplifier? And what is the speed changer? All the points we have already discussed. Now let us consider that the system is initially operating under a steady state condition. So what is the meaning of steady state condition? I will write it here. The system is operating under a steady state condition. The meaning of steady state condition is that there will be no change in the loading condition. So I will write it here, no change in the load. It is nothing but steady state condition. That is, if you see whatever linkage mechanism we have, ABC and the CDE, it will be a stationary and this pilot valve is a closed. So whatever diagram here shown, the same condition will be. This is the diagram for a steady state condition. Now if you see, the steam valve is opened by a definite magnitude speed of a turbine is in such a way that the turbine power output balance the generating load. Now what is the meaning of that? If you see how this steam inlet will be opened by the moment of this point E. We can say if the D moves in the downward direction, then what happens? This high pressure oil will enter from this and it will come into the main piston area and E will move in a upward direction. By how much amount your D will move in the downward direction, by the same amount will be E moves in the upward direction and it affects the steam inlet. So let us consider, okay, let me first reduce the size here. So let us consider, here I will write, let F0 is nothing but what? This will be a system frequency. This will be what? This will be a system frequency. Now what this 0 indicates? This 0 indicates at a steady state condition, or we can say whenever there is a no change. So F0 will be equal to what? This is a steady state condition. Now I will write it here as let PG0. Now G is the generation, P is the active power. So we can say that this will be equal to what? This will be equal to our generator output power, which will be equal to what? Turbine output, which will be equal to turbine output. As we know that now when we say unit, then unit is nothing but there will be a boiler, after that there will be blades of the turbine, and after that shaft, and then the generator will be. So generator output, whatever here generator output will be there, here we are considering that it will be same as that of your turbine output. So here I can write it as we are here neglect generation losses. So by neglecting generation losses, we can say PG0 will be equal to your generator output, which is same as that of your turbine output. Now Y suffix E0. Now what is the meaning of this? This is nothing but steam valve setting. Now why it is called as steam valve setting, and why here Y is written, why E is there, why 0 is there? Already we discussed why 0 is there, because here we are talking about a steady state condition. Now what is E? E is the point, if you see in the diagram, E is the point where your steam inlet is connected. It is the steam inlet is connected to point E. So that's why this is steam valve setting, point E. Now the question is, why here we have taken Y? Because if you see, the moment of the linkage mechanism will be in a upward direction or it will be in a downward direction. The moment will be what? The moment will be along y-axis, and it is not along x-axis. So that's why here what we have done, here we have taken Y-E0. Y is means what? E is the point where steam connection is there, and Y is moving vertically, that is along y-axis. That is your E point or D point, it will move along y-axis. Now let us consider that, I will write it here, let the point A in the linkage mechanism will be moved downward by a small amount. Let's say point A moves in the downward direction by a small amount. I will write it as delta YA. Now why we have taken delta YA? Delta is the small change, Y is because it moves along y-axis or vertically, and here we are talking about point A. Now it is the command which causes the turbine power output to change and which is given by. So here I will write the relationship between commanded power. So I will write it here as delta YA will be equal to Kc into delta PC. Mark this as a equation number 1. So what is this delta YA? Let us assume that point A. Now point A means what? Point A means where the speed changer is connected. So we know the relation. If A moves in the upward direction, B moves in the upward direction, C will move in the downward direction, D will move in the upward direction, and E will move in the downward direction. So basically whatever will be the direction of A, the opposite direction of E will be there. That is the steam inlet. So here if we see the equation, delta YA will be equal to Kc into delta PC. What is this delta PC? Here we can say this delta PC is nothing but it is commanded increase in the power. What is this? This will be commanded increase in the power. Let us consider this equation as equation number 1. That is delta YA will be equal to Kc is the constant into delta PC. Now if you see this delta PC is nothing but what? Commanded signal sets into the sequence as. What will be the sequence? First will be what? I will write it here. The pilot valve moves in the upward direction. That is, we can say D moves in the upward direction. Here now if you see here what we have taken, A moves in the downward direction. So if I write it here, A moves in the downward direction, B moves in the downward direction, C moves in the upward direction, D moves in the downward direction, E will move in the upward direction. If you see here already in a previous session, if you see this was the relation we have taken. A downward, B downward, C upward, D downward, E upward. So when the speed raises, then E will be close, and when the speed will be lower, which is denoted by upward arrow, because here the lower is denoted in the upward position, E will move in the downward position, means it will be what? It will open. So let's say here the pilot valve, what happens here? The pilot valve moves in the upward direction, that is D moves in the upward direction. What happens to the high pressure oil? So if you see, I write it here, the high pressure oil enters from the top. The high pressure oil enters from the top, and main piston will move in the downward direction. So let's see. So if D moves in the upward direction, here when D moves in the upward direction, so what happens? Here the position will be like this, up to this. I will draw it here like this. Okay, so high pressure oil will enter from this position. High pressure oil will enter from the top of the position, and this main piston will move in the downward direction because of this high pressure oil. And what happens to this? As E moves in the downward direction, whatever steam valve we have, it will be open. So I will write it here as high pressure oil enters from the top and the main piston moves in the downward direction. Point E, which is called as what? Which is called as your steam valve. Steam valve, it will be open. It will be open, and maximum steam will be allowed to enter to the system, or we can say turbine bed. And consequently, what happens because of that? As the maximum steam will enter, your speed omega will be increased. Speed of turbine generator, it will be increased. So let us develop a model for this condition, whatever here we have discussed. So what I will do, two factors will be contributing to the moment of C. So I will write it here. two factors contributing point C moment. Point C moment. Point C is nothing but what? Here, if you see, this is what is the point C. This will be the point C. So for the easy purpose, what I will do, I will make here one table, and based on that table only we will remember this derivation. So first of all, I will write it here. First will be your condition. Next is nothing but assumption. And here next is nothing but a diagram. So here you know that initially, as there is no load, whatever your linkage mechanism A, B, C, it will be along a straight line. So A, B, C, D, E are the linkage mechanism. Already we have discussed this. So now what happens here? Now I will write it here. First point is nothing but condition is what? A moves in the downward direction by a small change which is equal to delta YA. So already here we have seen in this point, here we have seen that this delta YA will be equal to Kc into delta PC. Already we have seen this equation number 1. Now at a point A, the change is delta YA. Now let us assume that the point B is at fixed position. Point B will be at fixed position. So how I will draw? Let's see, I will draw it the diagram here. This will be your initial position of your linkage mechanism, which is denoted by here dotted line. So I will write it as here, this will be your A dash, this will be B dash and C dash. Now what we have written here, what is our condition? A moves in the downward direction. Let's say A moves in the downward direction. Here this distance is delta YA. As you know, if A moves in the downward direction and point B is fixed, means what? It is pivoted at point B. So what will be the diagram? How the diagram will be? The diagram will be like this. The diagram will be like this. So this is your position A, or point A from linkage mechanism, point B and point C. How we have drawn this diagram? Please try to understand. A moves in the downward direction by delta YA and point B is fixed. So therefore A moves by delta YA, point B is fixed, so it is pivoted at B. So automatically C will move in the upward direction. So this will be change in the position which is denoted by delta YC. And already we know that what is the distance between these A and B? It is, let's say it is L1, and distance between these is nothing but L2. You will ask me, sir, from where it is there? So if you see, A to B distance is L1, B to C distance is L2. So from this, whatever diagram here we have drawn, now let me take the triangle. First triangle I will take it as A dash and B. Which triangle I am taking? A dash, B. So same way, can I take the other triangle also? It will be what? As I started here from A, then A dash, then B. So next triangle will be what? It will be started from this C, C dash and B. So I will write it here C, C dash and B. So from this triangle, can I write like this? A into A dash divided by, or we can say A dash will be equal to what? C, C dash. A dash will be equal to C, C dash, and A dash B, this is your A dash B. So what will be here? It will be a C dash B. This is basic. Already we have seen how to use the property of a triangle. So now if you see, therefore I can write it here. What is A dash? A dash, what is there? This will be your delta YA. Okay. Then what is C dash? I told you here, C dash is what? Change in the position at point C. It is a small change, so that's why it is denoted by delta YC. And your point will move in what? It will move along y-axis. So this will be delta YC. Now what is A dash B? If you see, A dash B is nothing but length L1. So I will take it as this will be equal to what? This will be equal to your length L1. Now what is C dash B? Now if you see, B C dash is nothing but L2. But as I am tracing this from right hand side to left hand side, that is C dash B. So instead of writing L2, what we have to write? Here we have to write minus L2. Why minus L2? Please try to understand. Because your BC dash is L2, but we are taking it from right hand side to left hand side, that is from C dash to B. That's why it is denoted by minus L2. So how I can write expression for delta YC? I can write it as delta YC will be equal to minus of L2 divided by L1 into delta YA. It is easy to understand. So for this I can say this L2 by L1 minus sign will be as it is. I will write it as this will be equal to your K1. Let's say it is a constant of proportionality. So what equation you got here? Delta YC equal to minus K1 into delta YA. So mark this as an equation number 2, because we are going to use this equation here further. This will be equation number 2. Now whatever equation we have, this is your equation number 1 that we already have written. Delta YA equal to Kc into delta Pc. And this is your equation number 2. Delta YC will be equal to minus K1 into delta YA. So I will write it here from equation number 1 and from equation number 2. How I can write? Delta YC will be equal to this minus K1 as it is. Now can I substitute here delta YA from equation number 1? Yes. Delta YA will be equal to what? Kc into delta Pc. So in place of this delta YA, I am going to write it so that it will be what? It will be Kc into delta Pc. What I did here, in place of this delta YA, I put the value from equation number 1. So how I can write the expression here? So delta YC will be equal to what? Minus K1 into Kc into delta Pc. Mark this as a equation number 3. So this was the first case. What was the first case here we have done? A moves in the downward direction by delta YA. Now let us see the second case. Second case is nothing but, here I will write it here second. Now how I can write? Increase in the delta F. Delta F is nothing but change in the frequency. Increase in the delta F. As you know, already in the previous video we discussed that whenever speed will be more, fly balls will move in the upward direction, and as fly ball moves in the upward direction, B will move in the downward direction. So increase in the frequency, I will write it here, causes the fly ball moves in outward direction. Fly ball moves in outward direction. That is, can I say that is point B will move in the downward direction. Point B will move in the downward direction. By what amount it will move in the downward direction? By, let's say, it will move by a delta YB. So therefore, from this, can I write like this? So you have seen here, there is a relationship between delta YB and delta F. By how much amount there will be change in the frequency, by that much amount your B will move either in downward direction or upward direction. So we can say that the change in the position of linkage mechanism of point B depends upon change in the frequency. So delta YB is proportional to delta F. So let's say this proportionality constant is K2 dash, and mark this as equation number 4. So this will be the second case, and this is what is, if you see, this is the condition. So I will write it here. This will be our condition. That is what? Point B moves in the downward direction. Now what is our assumption? Here we will assume that point A is at fixed point. Point A is at fixed point. So what will be the diagram here? So we have to draw the diagram. Initially, if you see, initially the position of ABC was this. I told initially here A, B, C. So I will represent it as, this is your points. I will represent it as a dotted line. Dotted line is nothing but it is initial, which is denoted by A dash. This will be B dash. This will be C dash. So we have to draw the diagram here for linkage mechanism. How we will draw? Refer this condition and assumption. Condition is what? Point B moves in the downward direction. So I will say point B moves in the downward direction here. Let's say it moves in the downward direction. So it will be delta YB. It will be what? Delta YB. And if you see, point A is at a fixed point. So if I draw the curve, or if I draw the diagram will be like this. Point A is fixed, it is not going to move. So B will move in the downward direction by delta YB. So change here, I write it as this is your B, this will be your B dash initial position, this will be C. So the moment of point C will be denoted by delta YC. Again, if you see, the distance between these two is L1 and distance between B dash and C dash will be equal to L2. So this is the diagram here we will get. Now based on, again I will apply a triangle. So first we will take triangle A, B dash, B. Refer this. Which one we are taking? A. Let's say this is a A. I will not take this as a A dash. This is your A, then B dash and B. So I have traced this triangle like this, A, B dash, B. So what will be the second triangle or second name of the triangle? I can take it as A, C dash, C, because first I have taken it as A, B dash, B. Second will be A, C dash, C. So from the triangle, can I write like this? I will write it like this. B, B dash. So B, B dash. So how I can write? Upon C, C dash. Yes, you can take it in this way also. B, B dash upon C, C dash will be equal to AB dash upon AC dash. AB dash upon AC dash. So how I can write expression? What is your B, B dash? If you see, B, B dash is what? Change in the position along Y axis at point B. So how I can write it? It will be your delta YB. Divided by C, C dash will be delta YC. Now what is AB dash? AB dash is nothing but what? This distance L1. So I will write it here. This will be your distance L1 divided by what is AC dash? It will be equal to what? L1 plus L2. So I will take it as L1 plus L2. So from this expression, can I write expression for delta YC? Yes. How it will be? It will be L1 plus L2 divided by L1 into delta YB. So for this, let's say constant of proportionality I will take, because anyway this is the fixed distance, it is not going to change. So let's say it is K2 double dash into delta Y. So what is your final equation? Delta YC will be equal to what? K2 double dash into delta YB. Mark this as a equation number 5 because we are using these equations. So again, from equation number 4 and equation number 5, how I can write? Please refer your equation number 4. What is your equation number 4? Delta YB equal to K2 dash into delta F. So what I will do here, I will write first equation number 5. So it will be what? Delta YC will be equal to K2 double dash. Now we know from equation 4 the value of delta YB is what? K2 dash into delta F. So I will put it here. It will be what? K2 dash into delta F. So K2 dash and K2 double dash, for this place I will write it as a constant as a K2 into delta F will be as it is. So what you will get here? Delta YC will be equal to what? K2 into delta F. Mark this as a equation number 6. Now if we want to write net change at a point C, so I will write it here. Net change at point C means what? Net change will be what? Delta YC. How we can write it? Can be obtained. So can be obtained. How it can be obtained? Let's add equation number 3 and equation number 6. So basically here what we are doing, we are using the superposition theorem in the mathematics. So it will be what? Delta YC will be equal to your equation number 3. Please see where is it? Where is your equation number 3? It is minus K1 KC delta PC. So I will write it here. It will be what? Minus K1 KC into delta PC plus K2 into delta F. Mark this as a equation number 7. So what is this? This equation is nothing but what? It will be net change at point C. Net change at point C. Now you know that what will be the moment of the pilot valve. So pilot valve moment, or we can say pilot valve, will be open by the moment of point D. If you refer a diagram, then you will be able to understand. When the D will move either in upward direction or downward direction, then pilot valve will be open. So let's say, again I will write it here, what is our condition, then next is nothing but assumption, and based on condition and assumption we will draw here a diagram. So what is our next condition? Now if you see here, let's say whatever will be change in the position point D, it will be what? Delta YD. Either it will move in upward or downward direction. Okay. So we know from the linkage mechanism, if you see, there will be C, D and E. We have C, D, E. In first two cases, we have taken ABC as a linkage mechanism. Now here we will be taking CDE, because here we are talking about a pilot valve. And where is a pilot valve? If you see, this will be your pilot valve, so which is connected to D, and the moment of whatever will be the moment of the D, the opposite will be the moment of steam inlet, that is at point E. So what we will do, okay, I will write it here. First, pilot valve opens by the moment of point D. Let's say the moment will be a delta YD. It is achieved by delta YC and delta YE. So what we have to do, we will take a third case. The third case is nothing but, let's say C will move in downward direction. Let's say C will move in the downward direction by the amount delta YC. By the amount delta YC, and let us assume that here E will be at fixed. E is fixed means what? Steam inlet will be at fixed position. So let's take this CDE linkage mechanism. So how we will draw? I will draw it here. This is your C, this is D, this is E. Dotted line represents its initial position. So C, this is D, this is E. So we can write it as C dash, D dash here. Now E is at a fixed point and C moves in the downward direction. So use this condition and the assumption. E is at a fixed point and C moves in the downward direction, means how your diagram will be? Your diagram will be like this. So C, this is D, this is E. So what is this? This will be delta YC. What is this? This will be your delta YD. E will be at fixed. This is what is our assumption here we have seen. Now what is the distance between C and D? It is L3, and distance between D and E, it will be L4. From where we have taken this? Let's see the diagram. Distance between C and D is L3. Distance between D and E is L4. So let's put this in this diagram. So again we are using the same triangle analogy here. So I will write it here, triangle E C dash C. How I have taken? E C dash C. So how to take a name of other triangle? It will be D, or you can say first is E C dash C, next will be what? E D dash D. E D dash and D. So how I can write here expression? Can I write like this? C C dash. So this will be your C C dash upon D D dash will be equal to what? Will be equal to, let's say, C dash E. So if you see, I have taken C dash E. So how I can write it as D dash E? It will be equal to what? D dash into E. Now let's try to substitute all the values here. So what I will get, therefore, C C dash will be what? Delta YC. D D dash will be equal to delta YD, equal to, what is C dash E? C dash E will be equal to L3 plus L4. So I will put it here, the value as L3 plus L4 divided by, now what is your D dash E? D dash E is nothing but your L4. So I will take it as here, it will be equal to what? It will be equal to L4. So can I write an expression here for delta YD? Yes, I can write it as delta YD will be equal to what? L4 divided by L3 plus L4 into delta YC. So in place of this L4 upon L3 plus L4, I can take one constant. So delta YD will be equal to K3 into delta YC. Let us consider, or let us take this equation as a equation number 8. And the last condition, assumption and the diagram. Condition, this will be your assumption and this will be your diagram. The last condition is nothing but, let's say I will give it here number 4. Here for this it was 3, previously it was 2. Have I taken this? Yes, I have taken. So let me write a condition 4 now. Let's say now there will be a moment of the point D. As you know, whenever there will be moment of the point C, but obvious after that there will be moment of the point D. So here I will write it as, if D moves in the downward direction by the amount delta YD. If D moves in the downward direction by the moment of what we can say delta YD. So how we can write it here? Let's say here the assumption is nothing but C is at a fixed position. C is at what? Fixed position. So how I can draw a diagram? Let me try to draw here a diagram. This will be the dotted lines. Dotted lines, what it indicates? It indicates it will be the initial point. So I will take it as C, D dash, and this will be your E dash. Now D moves in the downward direction. So I will put this point here. D moves in the downward direction and C is fixed. So how the diagram will be? The diagram will be like this. Okay, let me try to draw this properly. Okay, this point will be at this point. Don't take this point here. So this will be your point D. This will be your point E. So what is the change here? It will be delta YD and this will be your delta YE. So I have drawn this diagram based on this condition and assumption. D moves in the downward direction and C is fixed. That's why the nature of the diagram will be like this. So how we can write it here? Let me take here triangle. So which triangle I will take? I will write it here in triangle C D dash D. This will be C D dash D. So how I can write equation or a name of the triangle for the next? It will be what? It will be C E dash E. First one is what? C D dash D. Second one is C E dash E. So I can write it here as E dash upon D dash will be equal to what? C E dash upon C D dash. So therefore, if we write it here, how we can get the values here? Okay, let me write it here first. The distance between C D dash here, it is nothing but it will be L3, and here the distance is nothing but L4. So what is E dash? E dash is nothing but delta YE. So I will write it here. It will be equal to what? Delta YE. So this is delta YE. What will be D dash? This D dash is nothing but delta YD. Okay, so it will be equal to this delta YD. So how I can write now CE dash? If you see this CE dash, it will be equal to what? This distance L3 plus this distance L4. So I will write it as it will be equal to L3 plus L4. And how we can write for CD dash? CD dash will be equal to L3. So just substitute from the diagram. Already we have seen what is L3 and L4. So can I write equation for delta YD from this? Yes, I can write delta YD will be equal to what? L3 upon L3 plus L4 whole into what? Into delta YE. Into delta YE. So let me take some constant of proportionality for this. I will take it as delta YD will be equal to, for this I will write it as K4 into delta YE. K4 into delta YE. So this will be your equation number 1. Treat this as a equation number 1. So how I can write a net moment? I will write it as net moment of point D. Net moment means what? Let me take here as a delta YD. How I can write the equation for net moment of the point D? What we have to do? We have to add equation number 8 and equation number 9. So I will write it as delta YD will be equal to, now what is your equation number 8? Let me check here, K3 delta yc. So I will write it here, K3 into delta yc plus, if you see, equation number 9 will be K4 into delta ye. So this will be your net moment of a point D. So let me give equation number here 10. Now if you see, whatever will be the moment of a delta yd, it depends upon its sign. Opens one of the pilot valve, admitting high pressure oil into a cylinder, which causes the moment of a main piston, and opens the steam valve by amount of delta ye. Because by how much amount, let me again open the diagram, by how much amount the D will move in the downward direction, by the same amount E will move in the upward direction. And by how much amount of the oil, high pressure oil, will enter into the main piston, there will be a moment of a point E. Either it will be in a upward direction or it will be in the downward direction. So at this stage, there are some justifiable simplifying assumptions. So what here assumptions are? Inertial reaction forces of the main piston and the steam valve are negligible compared to that of the forces exerted on the piston by a high pressure oil. We know that as there is a moment here of point D and point E, either in upward or a downward direction, there will be some inertial reaction forces. So whatever inertial reaction forces of main piston and the steam valve, let us consider that it will be negligible compared to that of the force which is exerted on the piston by the high pressure oil. And the second assumption is that by considering the assumption number 1, whatever here we have seen, the rate of oil admitted to the cylinder is proportional to what? Proportional to delta yd. So here I can say the moment, here I will write it here, the moment of point D and point E are exactly opposite to each other. Are exactly opposite. What is the meaning of that? By how much amount your D will move in the downward direction, by that much amount E will move in the upward direction. So I will write it here, when D moves in the downward direction, when D moves in the downward direction, E will move in the upward direction. So therefore, and vice versa, whenever D moves in the upward direction, E will move in the downward direction. So I can say the change in the position of point D and change in the position of point E, it will be same, but it is negative. Why negative? Because when D moves in the downward direction, E will move in the upward direction with the same interval or with the same, we can say, distance. Similarly, if opposite occurs, then we have seen the opposite relation here. So what is the relation we got? Delta yd will be equal to minus delta ye, or in other words I can say delta ye will be equal to minus delta yd. I think you understood this, why the minus sign has been taken, because there will be a change in the direction or change in the position of point D and the point E. Now the moment, I will write it here, the moment, whatever will be the moment of a pilot valve, the moment of the pilot valve depends upon one factor. On which factor it depends? Upon how much amount of the oil enter into this, or in other words we can say that what will be the volume of oil enter, what will be the volume of, here I can say, oil entered into the cylinder or into the main piston, which will be depend on, I will say it will be depend on a time integral. It will be depend on the time integral of delta yd. Now here why we have taken delta yd? Because initial there will be change in the position of yd and it will create its own effect on the ye or E. So time integral means what? Time which is required to obtain the same manipulated variable as for the proportional action when using integral action is nothing but what? It is nothing but time integral. Now how I can explain this? Let me explain this by drawing a diagram. Let's see, this is nothing but your volume. Here how you can say this is nothing but your volume. How you can find it out? A volume, we know that volume will be equal to what? Area into height. This is a basic formula that we have seen. Now the point E, whatever we have, point E we have seen, it moves either in a downward direction or it moves either in an upward direction. Let's say the length is nothing but L, or you can say height is nothing but H. So how I can write the moment of a delta YE? So I can write it as the H or L, or in other words I can say delta YE, because here we are talking about point E only. Okay, so delta YE will be equal to what? Volume upon area, because here you know H will be equal to volume by area. Here H will be equal to what? Here we have taken it as a delta YE, height. So volume by area, volume means what? Volume is nothing but volume of the oil which is entered into the cylinder divided by area of the piston. So therefore mathematically I can write it as whatever will be changed in the position at point E, it is here we have written, it depends upon time integral of delta y. So time integral means how I can write? It will be, or I can write it as first it is delta yd. Okay, we know that relationship between this is minus, so delta ye equal to minus delta yd, and it is time integral, so integration of dt, time integral. And here let me take constant of proportionality k phi, because already we have seen that whatever will be the change in the ye, it depends upon your change in the position yd. So delta ye is proportional to what? Delta yd. So here let me take this as a equation number 11. So from whatever equations here we have seen, basically we are doing a modeling of this, and from this modeling we are going to construct a transfer function and then a block diagram. So I will write it here from equation number 7, then from equation number 10, and from equation number 11. How I can write? Well, which one is the equation number 7? Delta yc will be equal to minus k1 kc delta pc plus k2 into delta f. This was your, I will write it here from equation number 7. Okay, so if I want to take a we can say whatever transfer function, then we have to take here Laplace transform. So take a Laplace transform of this equation. So I will write it as delta capital YC of S will be equal to minus k1 kc delta pc of S plus k2 into delta f of S. So take this as a equation number 12. What we did here from equation number 7, we have taken Laplace transform, so we got this equation, that is equation number 12. Now from 10, what was your equation number 10? Delta yd will be equal to k3 into delta yc plus k4 into delta ye. For simplicity, I will write it here from 10 here, or this is the equation number 10. So again we are taking here Laplace transform. So what we will get? Delta yd of S, here we are taking capital Y, will be equal to k3 into delta yc of S plus k4 into delta ye of S. Okay, so let me take this as a equation number 13. So what we did, we have taken a Laplace transform of equation number 10, and what is equation number 11? It is delta ye will be equal to minus k5 integration of delta yd into dt, delta yd into dt. I can write it here. We got this from equation number 11. So by taking again a Laplace transform of this expression, I will get delta ye of S will be equal to, what is the Laplace transform of integration? It will be 1 by S. So minus k5 upon S delta yd of S. Mark this as a equation number 14. Now what I will do, I will write what substitutions we have to do. I will write it here. Put the value of delta yc of S from equation number 12 to 30. What we have to do? Here again I will repeat. we got this equation number 2 of delta yc of s. So we will put this delta yc of s value here in equation number 13. So what I will get? I will write it as, therefore delta yd of s will be equal to, I am going to put the value of delta yc of s from 12 into 13. So delta yd of s will be equal to k3. Now next is delta yc of s. So in place of that, what I am going to write? I am going to write equation number 12. What is your equation number 12? Minus k1 kc into delta pc of s plus k2 into delta f of s, bracket close, plus remaining term it was the same, k4 into delta ye of s. Let me take this as a equation number 15. Now what I will do? I will put this equation number 15. So I will write it here. Put equation number 15 into equation number 14. What we have to do? Put equation number this 15 into the previous equation, that is 14, delta ye of s. So I will write it here. Delta ye of s will be equal to minus k5 upon s will be as it is. So what I will do here first, what is this? This will be delta yd of s. So this was your delta yd of s, k3 delta yc of s plus k4 delta ye of s. So directly what I will do, okay, let me write this equation first for understanding. So first I will write it here as k3 into delta yc of s plus k4 into delta ye of s. How you got this? I think you got, all of you. This is which equation? This is equation, this delta yd of s. So I am putting 13 into 14 first. Okay, let me correct here. I am put 13 here instead of 15. I will write it here, put 13 into 14. So I got this. So how I can separate now? Let me separate this term, minus k5 into k3, okay, into delta yc of s whole divided by s, and if I take this minus k5 by s inside, then it will be minus k5 k4 delta ye of s whole divided by s. I think you got this expression. So now how I can write it? So therefore delta ye of s will be equal to, now what I will do, minus k5, it will be a k3, okay, divided by s, and now I am putting this delta yc of s equation. I am putting this delta yc of s equation. What is this? Minus k1 kc delta pc of s plus k2 delta f of s. Means what I am doing? I am putting this equation number 12. I am putting this equation number 12 in this place, delta yc of s. So what I will get? I will get it as minus k1 into kc into delta pc of s, okay, so plus k2 into delta f of s. Again let me show it to you. This is the equation, minus k1 kc delta pc of s plus k2 into delta f of s, that I have substituted here, in place of delta yc of s, and I will write this as it is, minus k5 into k4 into delta ye of s whole divided by s. I am putting this term as it is. So what I will do from this equation, whatever here you have observed, now can I do one thing? I will write it like this, delta ye of s. I will take this delta ye of s towards this side. So this negative term will be shifted towards this side. So what it will be? Here the 1 plus what you will get? k4 into k5. k4 into k5 divided by s. What I did? Just I have shifted this. I have shifted this term, minus k4 k5 delta ye of s upon s, towards left hand side, and I have taken this delta ye of s common, which will be equal to Now do multiplication inside. So what I will get here, I will get it as minus minus becomes plus, K1, K3, K5. So I will write it here, K1, K3, K5, this Kc will be there, then into delta Pc of S. Okay, now minus, if I take this term inside, then what it will be, K2 into K3 into K5 into delta F of S. I will put whole divided by S. Instead of writing it here separate, I will put it as whole divided by S. So again, now what I will do, I will shift this term towards this side. So I will be able to write equation for delta YE of S. So how we can write? Numerator will be as it is, K1, K3, K5, Kc, delta Pc of S minus K2, K3, K5 into delta F of S. This whatever we can say numerator will be, it will be as it is, whole divided by S as it is, and I am shifting this towards right hand side. So it will be what, 1 plus K4 K5 upon S. So we will get this expression. Now what I will do, I will do some adjustments. What adjustments? Divide numerator and denominator, that is to the RHS side we are talking about, by K5, by K5, or we can say take common and cancel out, take common and cancel out. So you can write it in any way. So if I divide it by K5, then what you will get, K1, K3, K5, K5 will get cancelled, Kc into delta Pc of S minus K2, K3, K5, K5 will get cancelled, delta F of S whole divided by this S will be as it is. Now I am dividing it to denominator also. So how it will be? It will be 1 upon K5 plus K4 upon S. K4 upon S. Okay. So if I multiply this S inside, then what I will get? I can write it as K1, K3, Kc, delta Pc of S minus K2, K3, delta F of S as it is. Numerator will be as it is. I am going to multiply this S inside. So how it will be? How I can write? It will be S upon K5 plus K4. S upon K5 plus K4. Now what I will do? Take common. I will write it here. Take common. Which term? K1, K3 and Kc from numerator. Take common this from numerator and take common K4 from denominator. K4 from denominator. So how your expression will be? Delta YE of S will be equal to, I am taking this K1, K3, Kc common from numerator and K4 common from denominator. So how I am going to write it? What will be your expression? Your expression will be like this. I will write it here. Now as I am taking K1, K3, Kc common, so first term will be delta Pc of S minus, now here K1, K3, Kc I am taking common. So if you see this K1 and Kc, K1 and Kc will be what? It will be at denominator, and here you will get K2 into delta F of S. You try to multiply, you will get the same term. K1, K3, Kc, if you multiply it inside this, what you will get? K1, K3 will cancel out, K3, K2. So here you will get K3, K2 and delta F of S. Means whatever term here we have written, it is correct. This bracket complete. And what we did here? K4 has been taken common from the denominator. So I can write it here as S upon K4, K5 plus 1. So yeah, if you multiply it, K4 inside, if you take it inside, K4 will cancel, you will get S upon K5. So you will get the same term. So this equation here we will get. So finally I can write it here. Therefore delta YE of S will be equal to what? KSG upon 1 plus S into TSG into bracket delta PCU of S minus 1 by R into delta F of S, where if you observe here, where what is the value of KSG? This KSG will be equal to this term. This term is nothing but KSG. So K1 into K3 into Kc divided by K4, you will get this as a KSG. You will get this as KSG. This KSG is nothing but it will be a steam governor gain. It will be what? Steam governor gain. Then if you see what is TSG, this TSG will be equal to 1 upon K4 into K5. So let me show you this 1 upon K4 into K5. It is nothing but what? It is TSG. So you will get 1 plus S into TSG. So what is this TSG? Let me write here. The meaning of TSG is nothing but it is steam governor time constant. Steam governor time constant. This SG here, it stands for steam governor or speed governor also. You can say speed governor also. And what is your R? R will be equal to K1 Kc upon K2. So let me show you here. If you see here, this will be your, this term here we have written it what? 1 by R. So what will be the R? K1 Kc upon K2. So what this R stands for? This R is nothing but regulation of a generator. So I will write it as regulation of a generator. So please now refer this equation, whatever here we have drawn, and from this now are we able to draw a block diagram? Yes, we will be drawn. We can draw it. This will be your output, then this will be your input, okay, and this 1 by R is nothing but a feedback. So how I can draw? So I will draw it first. Output. What is your output? Output is nothing but delta YE of S. So I will draw it here. Output is delta YE of S. Which one is the input as far as this equation is considered? Delta PC of S. Before that this will be a gain, KSG upon 1 plus S into TSG. So let me draw, because it will be a multiplication. So how I can draw this in a block diagram? It will be what? KSG upon 1 plus S into TSG. And what is to be there here? Delta PC of S, which is the plus. So I have to take here summing block. So this will be what? Delta PC of S, which is nothing but plus. Okay, so output will be here. And what is the next step? Minus 1 by R into delta F of S. So as I told you, this 1 by R is nothing but a feedback, and which will be a minus. So here we will get it as a 1 by R, and to this input is nothing but delta F of S. So this is the partial completion of single area load frequency control complete block diagram. So we can say this will be a transfer function or the model, I can say a model of speed governor, turbine speed governor system. Turbine speed governor system. So if the question is asked, write down the model and draw the diagram for the speed governor system, then whatever points here today we have discussed, we have to write it here. So this is what is the topic of turbine speed governor system with its modeling. If you have any doubt, please feel free to ask any queries. You can write down a comment and you can ask me a questions. Thank you for watching this video. Once again, thank you.